Very good morning. Shall we start? So today we'll start the most important topic, that is hydrostatic forces. Okay, hydrostatic forces. Right. वॉल्यूम कम करेंगे. Right. Hydrostatic forces. Now, still we are in static fluid. See, whenever the fluid is under static conditions, I repeat, whenever the fluid is under static conditions, the shear force is zero. There are only normal forces. There are only normal forces. I repeat, my dear students, we are dealing with hydrostatic forces and we will see practical applications of this. Now, whenever the fluid is under static conditions, there is no shear force, because fluid is a substance which flows under the action of shear force. When there is no shear force, it will be under static conditions. So there are no shear forces. There are no shear forces. So there are only normal forces. And you know, those normal forces are pressure forces. Chalo, you might have seen, my dear students, overhead tank. बिल्डिंग के ऊपर आपका सिंटेक्स टैंक है, or you have constructed with a concrete. Maybe the shape of the tank is like this. Tank may be like this. देखो एक बार. Or it may be like this. Right. So when this tank is filled with a fluid, when the tank is filled with a fluid, definitely this fluid will exert force on these walls. On these walls. Yes, it will exert force on these walls. On these walls. On these walls. On these walls. See, you take this, you have this. Let us assume that I have filled this with a liquid. I have filled this with a liquid. So that liquid is exerting force on this surface. It is a curved surface. It is a curved surface. It is a curved surface. And if you take this one, it is a plane surface. Plane. It is a plane surface. So I will divide this chapter into two parts. One is hydrostatic force on plane surfaces. What do you mean by plane? For example, you take this. There is a fluid this side. There is a fluid. The fluid is exerting force on this. It is a plane surface. Plane. And let it be like this. Like this. Now the fluid is exerting force. It is a curved surface. So I will divide this into two parts. One is plane and one is curved surfaces. So first I'll talk about forces on the plane. For example, this is a water tank, rectangular shape, मान लो. The fluid will exert a force on this plane surface. So it is a plane vertical surface. It can be like this also. See, for example, it can be like this also. So on this the fluid may be exerting force. It is plane but inclined. It is plane but vertical. It may be like this. Now it is plane horizontal. So we will divide this into two parts. Hydrostatic forces. First is plane surfaces. And under plane, I'll divide it into three. Under plane, we'll divide it into three. plane horizontal, plane vertical, and plane inclined. So we'll discuss these three in detail. Plane horizontal, plane vertical, and plane inclined. Then we'll go to curved surfaces. So now our topic is hydrostatic forces on plane surfaces. Very good. My dear students, in plane surfaces, first I'll take inclined surface. I repeat, in plane surfaces, first I take inclined surface. So let this be free surface. Let this angle be theta. It is an inclined surface. My dear students, if I make theta 90 and if I make theta 0, इसको horizontal बना देंगे तो theta will be 0. Theta is 0. So first I'll derive it inclined surface. So from the inclined surface, if I put theta 90, you get vertical. If I put theta 0, you get horizontal. So therefore, you don't have to worry about this. Now, in this chapter, there are two things that I am interested in. First is, what is the magnitude of the force exerted by the fluid on our surface? फिर से बता रहा हूं, सुनो. Let us assume this is the surface and here we have water. This is the surface and here we have water. How much force the fluid is exerting on our surface? Point number one. That we call it as hydrostatic force. कितना force exert कर रहा है? Second one. We have seen how much force. And second one. Where is that force acting? The point of application of that force, because we will be dealing with equilibrium. For it is hydrostatic. For static equilibrium, not only forces must balance, moments must also balance. तो moments को अगर balance होना है, you need to know the point of application of force. So please, my dear students, in this complete chapter, we are always interested in two things. One is, what is the magnitude of the force, which we call it as hydrostatic force. And the second one, where is that force acting? That is second one. Now, let's try to find out the hydrostatic force on plane surfaces. Let us try to find out the hydrostatic force on plane surfaces. But I will take inclined surface. So, देखो, till now is it clear, my dear students? चलो आगे बढ़ते हैं. Now, this is a wonderful topic and I'll try to cover in a neat manner. चलो, look at. मान लो, now come back to the subject. Let this be the free surface. What do we mean by that? This is the free surface. Free surface. What do you mean by that? Here there is atmospheric air. Let us take a liquid. यहाँ पे पूरा liquid ले लेंगे. We'll take a liquid. Now, let us take an object which is immersed in this. Maybe like this. देखो एक बार. something. It's like this, my dear students. Please observe here. An object is kept like this. This is all water. ये पूरा पानी है. So you can see only this portion. You can see only this portion. Actually, the object is this. This is the area. This is the area on which the fluid is exerted. Actually, it's like this. This fluid. This side there is a fluid. I will show if there is a fluid on this side, it will exert force like this also. But I am showing the force on one side. One side. So if there is a fluid on other side, it will exert. Let us take there is a fluid on one side. Very good. So there is a fluid on one side. Ab dekho. This fluid, whatever the fluid is, let this be the free surface, and the object is like this. Okay, and you are seeing, देखो एक बार, you are seeing this portion which I have shown, this wala, ये wala, this one. You have seen only this portion, but actually it is ये wala है. So therefore, if you see the other side, it will be like this. This is our object. Please note down that it need not be rectangular shape. It can be of any shape. It can be of any shape. Irregular, whatever it may be. Just for your understanding, I have shown here. No problem. No problem, my dear students. Yes. अब देखते हैं. Now we'll proceed. Now we'll proceed, my dear students. This is the object. Yeah. Let the inclination angle, let the angle of inclination let this be theta. Can you tell me what is theta? It is the angle made, I repeat, it is the angle made by this surface with respect to the free surface. Free surface से कितना angle कर रहा है ये, that is theta. Okay, I will mark this point. I will mark this point as some O. Okay, no problem at all. Very good. It's something like this, my dear students. There is an object. This side there is a fluid. So it is a static fluid. So definitely whenever the fluid is static, the forces are pressure forces, that is normal force only. The forces are coming on this due to normal because it's not flowing or moving. So therefore there is no shear. There will be only normal. There will be only normal. So normal force is nothing but pressure. Absolutely fine. So on this, actually we have shown this portion. If you see the other one, so the force is coming on this area. Okay, please note down that it need not be rectangular. It can be any shape, any irregular. जो भी shape है. Now, let this be so I have taken this. Okay, let this be B, let this be D. Some values. Okay, fine. Now, what we do is, let us try to draw one diagram known as pressure diagram. Okay, let's try to draw that. मान लो yes, let this height, ये वाला, let this height, let this height be x1, and let this height, look at this height, this one, this one, this one, this one, this one, let it be x2. Very good. Let the density of the fluid, so this, there is a fluid, who is exerting that force on the surface? My fluid. Let the fluid density, जो fluid which is exerting, let the density of the fluid be rho. Rho is fluid density which is exerting force on our body. Now, stop, my dear friends. Can you tell me, here the fluid will exert a pressure, and how is that pressure? It is always normal to the surface. Pressure is always normal to the surface. Pressure is always normal to the surface. So therefore, now look at, my dear students, to this surface, so I will show normal. To this surface, it will be normal. Okay. My question to you people is, what will be this pressure? It will be rho. Who is exerting that fluid? Rho G x1. Rho G x1. Rho G x1. Because the depth here is, this depth is x1. At a depth x1, we have seen in pressure chapter, at any depth h from the free surface, the pressure is rho gh. So at a depth of x1 from the free surface, the pressure is rho gx1. What is this? It is the pressure exerted by this fluid on our surface. Pressure is always normal to the surface. Okay. Now let us say, what is the pressure here? I repeat, let's say, what is the pressure here? What is the pressure here? And can you tell me what will be the pressure here? The depth is x2, it will be rho gx2. I repeat, यहाँ का pressure कितना होगा? Rho gx2. How will be that pressure? It is always normal. So which pressure is more, my dear students? Which pressure is more? This one, rho gx1 or rho gx2? Definitely rho g is constant. Depth x1 is less, depth x2 is more. Pressure increases with depth. So definitely compared to this pressure, so at this point the depth is more, the pressure will be more, and obviously that pressure will be normal. That's why I have shown with respect to this, इसका length ज़्यादा दिखा है, इसका length ज़्यादा दिखा है. So this is our, now I will write this as rho gx2. Absolutely. We know, my dear students, pressure is equal to rho gh or rho gx, whatever it may be, depending on depth. So rho is constant, g is constant. Can I write pressure is directly proportional to x? See the power of pressure and depth. Both have power 1, means the variation of pressure is linear. Linear means straight line. So with depth, the pressure is increasing linearly. So therefore, now यहाँ से यहाँ तक कैसे बढ़ रहा है? Linear means straight line. This is the variation of pressure. This is the variation of pressure on the surface. Yes, and this diagram is known as this diagram is known as pressure diagram. This diagram is known as pressure diagram. Pressure diagram. It is known as pressure diagram. This is known as pressure diagram. Pressure diagram. Pressure diagram. Now we have to calculate two things. I repeat, now we have to calculate two things. First, because of this pressure force, what is the total force acting on this area? So my surface is like this. So on this surface, the width is b, depth is d. So the fluid is exerting normal force. Here the pressure is rho g x1. Here the pressure is rho g x2. And with depth, the pressure is increasing. Because of that pressure, what is the total force acting on this surface? And that is known as hydrostatic force on the surface. And why that force is coming? Because of this pressure, normal force. It is a static fluid. So therefore, point number one. After finding out the magnitude of the force, the second one is where that force is acting. And that point where this total force, see my dear friends, we have to calculate the total force. It's called total force. We have to calculate the total force due to this fluid which is exerting on the surface. And that force is known as, the total force exerted by this fluid on this surface is known as hydrostatic force. Second, where is that force acting? And that is known as center of pressure. What is center of pressure? The point through which the hydrostatic force is supposed to be acting. जिस point से hydrostatic force act करता है, the point through which the hydrostatic force is acting is known as center of pressure. So in this chapter, we are always interested in two important points, two important parameters. One is magnitude of the force, second, and one is where that force is acting. Now let us calculate the magnitude of hydrostatic force. Okay. Now, let us proceed, my dear students. Let's proceed. Aram se, no tension. Let's proceed neatly. Yeah, please observe here. So what we do is understand very carefully. Let us take a free surface. Okay, and we'll take our object. Okay, this is our object, and this is making an angle. देखो एक बार. This is the object. Yeah. And this angle is your theta. What is theta? The angle made by our surface with respect to free surface. Okay, no problem at all. Not at all a problem. Chalo. Next. Okay. Now let us try to find out the magnitude of the force. Okay, no problem at all. एक काम करते हैं. I'll ask you a very simple question. The question is the pressure constant throughout the surface? Absolutely no. If you see clearly, this pressure here is different, pressure here is different, pressure here is different, so pressure is changing. So whenever something is changing, my mathematics is ready. What is that? Whenever something is changing, we always take small changes. For example, what we do is, अब देखना please, we'll take this color so that you can understand better. Okay, let us take some point. I have taken. Let this depth be x. The same point I am showing here. Let the depth be x. Can you calculate the pressure here? I repeat, can I calculate the pressure here? Yes, I can calculate. And At a depth x, the pressure is rho gx. Who is exerting that? Fluid. So always it is normal, and it is always normal to the surface. Yes. So I will write this as rho gx. Very good. It is always normal to the surface. Now, what I do is, I will take small area. I repeat, I will take small area. The reason for taking the small area is, look at carefully. If I take large area, so for example, from here to here, what is happening? This x is different. This, if I take this much area, for example, if I take this much area, this x is different, this x is different. So pressure here is different, pressure here is different, pressure here is different. So I cannot do it. So I have taken very small area, something like this, very small area, and the variation of x is very negligible. When variation of x is very, very small, when x variation is very, very small, in this small area, the pressure is almost the same. In this small area, the pressure is almost the same, almost the same, almost the same. I repeat, my dear students. So I have taken at a depth x, at a depth x, the pressure is rho gx. So if x ka variation is very small, when x change is very small, in a small area, let us take this area as dA, this small area. In the small area dA, the pressure is rho gx only. Why? Because it is very small, the variation of x is very negligible. X ka variation, dekho, if you take this as x, in this the variation of x is very, very small, very, very small. So I assume pressure to be uniform. So if I assume pressure to be uniform in the small area, what will be the force? We know that pressure is equal to normal force by area, or force is equal to pressure into area. So as I have taken small area, I will write small force. That small force is equal to pressure. So what is the pressure on this? It is rho gx is the pressure. That is the pressure into area. What is this area? Small area dA. So can you tell me what is this? It is the force exerted by the fluid on the very small area. But I want the total force. My mathematics is ready. Whenever you want total force, you just integrate this. Whenever you want the total force, you just integrate it. Rho gx dA. Whenever you want the total force, you just integrate. It is rho gx dA. So this will give me total force. If I integrate throughout the area, I'll get. So that can be written as, the density is almost, can I write rho g as W? Yes. So it is W x dA. So specific weight is assumed to be constant. So take it out. So this will be integral x dA. And you will be studying in engineering mechanics. You have already studied in your earlier classes. So from engineering mechanics, this integral x dA, I repeat, integral x dA is written as a x bar. I will tell the meaning of everything. This is from your basic engineering mechanics. Which you will be studying, or already you have studied at your engineering classes. So therefore, what is A? It is the total area. What is A? It is the total area. X. And please note down that you have taken x as what distance? You have taken x as what? Vertical distance. X is vertical distance from the, all distances are measured from free surface. So therefore, here x bar is nothing but vertical distance of center of gravity of that body from the free surface. Let me tell what is x bar. Idhar dekhna. What is x bar? Very simple, my dear students. X bar means, let us assume that this is my center of gravity. मान लो बॉडी का center of gravity यहाँ पे है. तो x bar is nothing but from the free surface. This is the free surface. This is the center of gravity of this surface. मान लो this is the center of gravity. Assume this to be center of gravity. This is our x bar. Can you tell me what is x bar? It is the vertical distance of center of gravity. It is the vertical distance of center of gravity measured from the free surface, that is x bar. So therefore, now if you want hydrostatic force F, it is W, that is specific weight of the fluid. What is integral x dA? It is A x bar. So don't do anything, my dear friends. This is the equation of hydrostatic force. Mind में fix कर देना. W A x bar. W A x bar. W is specific weight of the fluid, which can be written as rho into G. A is area of that surface. X bar, vertical distance of center of gravity from the free surface. I'll give you a simple example so that you can understand this very in a better manner. This is the surface on which I want the force. देखो एक बार, कुछ मत करना. Don't do anything. Please listen now. I want the force on this. Okay. Let us take. What is the equation that you got? W x bar. अब देखो. Let this be the free surface. Let this be the free surface. Okay. Now, we'll take our surface. Yeah. Now, मान लो this to be our center of gravity. Assume this to be center of gravity. This is our x bar. Can you tell me the meaning of x bar? Yes, first moment. X bar. What is x bar? Vertical distance of center of gravity from the free surface. Vertical distance of center of gravity from the free surface. This is x bar. This is x bar. This is x bar. Absolutely fine. अब देखो. Now look at my dear students. Area. अभी तो बताया. Just now I have told you. Area. And you know it very well. Area. I'm not following drawing rules. You are not supposed to cross lines in drawing. But anyway, this is the area. This is the area. So if I know this width, if I know this, and if I know this, I can easily calculate the area. In this case, the area can be written as, in this case, it is B into D area. So what is the equation for force? देखो एक बार, what is the equation for force? W A x bar. So what is W? Fluid specific weight. Okay, I know. Area. Yes. X bar. Vertical distance of center of gravity from the free surface. This is the equation for hydrostatic force. Please tell me, is the equation for it is a plane surface. We have not brought curved surfaces into consideration. It is a plane surface. Please tell me, is the equation for hydrostatic force on the plane surface clear? Clear, my dear students? Come on, waiting for your responses. Is it clear? Very good. If this is clear, what is our next target? Anyone? What is our next target? Force to aa gaya. What is the next target? Point of application of that force. And please, my dear students, be clear. I never said, and in fact, वो बात ही नहीं है. So I never said. Please listen carefully. This is the force. Now we have to say where from that force is acting. We have to say कहाँ से वो force act कर रहा है. From where the force is acting. That is center of pressure. I never said it is acting at CG. CG, center of gravity se to the weight of that object will act. Weight of that object. But the force is coming due to the fluid. And that is due to pressure. My common sense says, if you see why the force is coming, observe, why the force is coming. The force is coming due to, listen all of you, that force is coming due to pressure. That force is coming due to pressure. That force is coming due to pressure. Absolutely. That force is coming due to pressure. Whatever the force we have calculated, it is coming due to pressure. Is the pressure constant throughout? No. Is the pressure constant? No. And you know it is increasing with depth. So depth के साथ बढ़ रहा है. Depth, with depth it is increasing. With depth it is increasing. And if you understand clearly, see, if you understand clearly, with depth it is increasing, with depth it is increasing. So obviously that force is coming due to, listen carefully, this force is coming due to pressure, but pressure is increasing with depth. So where will be that resultant force? Actually the force is coming due to pressure, but pressure is increasing with depth ke saath. So where will be that? So if the center of gravity is here, say if this is the center of gravity, मान लो, if this is the center of gravity, where will be that force? You tell me now. If the center of gravity is here, but that force, this force is due to pressure, and with pressure the depth is increasing. So definitely the pressure is more at the bottom. So the resultant of that force is coming due to pressure. Pressure is more at the bottom. The resultant of that force will definitely be below the center of gravity. Will definitely be below the center of gravity. Yes, exactly, Amit. It will be constant. The force is coming due to pressure. The force is coming due to pressure. Where is the pressure more? Depth. Bottom it is more. So therefore, the point of application of this force, which is due to pressure, will shift below the center of gravity. That's why the center of pressure, or the point through which this total hydrostatic force is supposed to be acting, it will not lie at G, but it will lie below G, because where that force is coming due to pressure, pressure is increasing with depth. So therefore, it will lie below the center of gravity. Now we have to calculate. Now my second point is the point of application of force. This is very, very important. So therefore, I write center of pressure. Center of pressure. It is the point through which hydrostatic force is supposed to be acting. जिस पॉइंट से हाइड्रोस्टैटिक फोर्स एक्ट कर रहा है, and that we call it as center of pressure. Now let us try to find out the point of application of that force. Now please, you have to be very careful, and I am going to give you the complete derivation. Some students may be saying, sir, directly you give the equation, that is enough now. No. We do not know what type of questions are going to come in examination. So he may be asking from the middle, derivation के बीच से पूछ सकते हैं questions. So that's why I will not take any risk. I will do it. I will give the complete derivation to you. I'll give the complete derivation to you. So now the target is to find out the center of pressure. Now the target is to find out the center of pressure. Okay. Very good, my dear students. Very good. What is our target now? To find out the center of pressure, to find out the position of center of pressure, position. Okay, no problem at all. Absolutely fine. No issues at all. Let's try to find out, my dear students, कहाँ से act कर रहा है, where from it is acting. Let's find out in a detailed manner. लाइंस भी सही नहीं आ रहा है, देखो ये भी नमूना है की तरह, कोई बात नहीं, विल टेक इट। ओके, now the main aim here is to calculate the center of pressure, मतलब जिस point से act कर रहा है, so from where it is acting, let's try to find out, right? अब देखते हैं, now let's do it very neatly, listen carefully. Let us take a body, okay, and if you see the other view, please listen. Okay, so I'll show you this view also. एक काम करते हैं, wait for 1 minute please, I'll show you this view also. See, derivations are very important. Yes. So if you see the other part of this body, now we are trying to find out from where this force is acting. Yeah. Right. Now, हो गया. Let's see from where this force is acting. देखो एक बार carefully देखो. I told you very clearly. हाँ. Let this angle be theta. Let us take this point as O. Now you draw a perpendicular, my dear students. Let's draw a perpendicular. इसको perpendicular draw करना. Let this be O dash, and this O dash. Listen, this O dash, this both are parallel. ये और ये parallel है, ये और ये parallel है, and obviously this is 90 degree. This is 90 degree. Okay, no problem at all. No problem at all. See, this is very important derivation. This is very important derivation. Very good, my dear students. Now, okay, this is the free surface. This is the free surface. Okay, no problem. Let's take any point. Let's take any point. Let this be at a distance x from the free surface. So rho is the density of this fluid, rho is the density of this fluid, rho is the density of this fluid. Let it be at any distance x from the free surface. Okay, no problem at all. Now, you know very well, this fluid will exert a normal force on this. So what is the pressure here? What will be the pressure here? The depth is x. If the depth is x, what will be the pressure here? Rho gx, and that will act normal to this. Yes, no problem at all. No problem at all. Now let's proceed, my dear students. आराम से. चलो. Yes, no problem at all. Right. Very good. अब देखते हैं. Now, please understand carefully. Let us try to see. And what we do is ये वाला. This is x. Let us take this as y. What does it mean? It's like this. What is this vertical distance? What is this vertical distance? X. This is y. It's like this. Okay, 1 second. Please don't be in hurry. Let me do it very clearly. क्योंकि confusion नहीं होना चाहिए. That is the main aim. Yes, this length is x, this length is x, and it is y. Can I write the relationship between x and y? Yes, I can write. Either dekhna. Can I write? So it's like this is x, and this is y, and this is theta. Dekho, this is y, this is y, this is y. This vertical is x, and this angle is theta. What is sine theta? Sin theta is equal to x by y, or x is equal to y sin theta. Similarly, for example, I'll do one thing. Similarly, let us assume this to be the center of gravity. मान लो this to be the center of gravity. So I will write this as x bar. Now corresponding to x bar, I will write this as y bar. Please listen. So if this is x, listen carefully. If this is x, this is y. If this is x bar, this will be y bar. If this is x bar, this will be y bar. If this is xcp, this will be ycp. No problem at all. So can I get the relationship between y bar? Very simple. X is y sin theta. Similarly, x bar is equal to y bar sin theta. Because if I take this triangle, please tell me, all of you, are you getting? All of you. This is, I'll write it as G, means centroidal axis. This is GG. G ka matlab center of gravity. This is some arbitrary point. This is some random point. This is the center of gravity. So this is GG, GG, GG. This is centroidal axis. ये center of gravity है, तो this is centroidal axis. ये center of gravity. It's like this. If here we have center of gravity, so this will be centroidal axis. Here we have center of gravity, so this will be centroidal axis. So I'm showing this only. So अगर यहाँ पे center है, तो this is G. This will be center of gravity. The center of centroidal axis. Centroidal axis. यहाँ तक सबको समझ में आया? All of you, are you there? All of you, are you there? Shall we proceed? Shall I proceed? If you say yes, then I'll move ahead. Yes, very good, very good, very good. Very good, very good. Excellent, excellent, excellent response. Excellent response. Come on, come on. Come on, my dear students. Ab dikhte hai. Now stop. Let us proceed. So, we have written this. Okay, no problem at all. No problem at all. Ab dekho, please. Now, understand. Dekho. What we do is, please understand, my dear students, let us calculate force here. What is the force here? Small force. Either all of you look at force is equal to pressure into area, because pressure is equal to normal force per unit area. If you want force, it will be pressure into area. So we are calculating the force on the small area. Can you tell me why are we calculating on the small area? The reason is, if I take large area, my x will vary. When x is varying, pressure will vary. Pressure cannot be uniform throughout that large area. So therefore, let's take dF is equal to, what is the pressure? Rho gx. What is the pressure here? What is the pressure here? Rho gx, rho gx, rho gx, rho gx. So if you want the force into this area, very small area, this I write it as dA. This I write it as dA. So we are calculating the force in the small area, that is df is p into dA. Excellent. Awesome, my dear students. What we do is, hold on. What we do is, listen carefully. I will take the moment, listen carefully. I will take the moment of this force about this. So, you know, my dear students, it is x. It is x. So, this is y. This is y. What is the moment of this force about? देखो, कहाँ पे moment ले रहे? Where are you taking moment? Where are you taking moment? That is very, very important. Where are you taking moment? That is very important. I'm taking about OO dash. I'm taking about OO dash, OO dash, OO dash. So what is the moment? Rho gx is the force. I'm taking moment. Actually, rho gx, and for this it is perpendicular. For this it is perpendicular. So इसके लिए ये perpendicular है. So what is the moment of this small force about OO dash? About OO dash. So it will be rho gx into y. Rho gx into y. I repeat, this is rho gx force. What is the force? This one. React. This is only pressure. If you want force into area, so I will multiply this with dA. So if I multiply with dA, what do I get? This is the force. This is the force, and this is the force. And if I want moment, force into this y. If you want moment, this force into y. This force into y. So I will do like this. Moment of this force df about, कहाँ पे ले रहे moment? About this, about this, about this. And people should focus on this. You'll be seeing the beauty of this little later. Yeah. Okay. Now, can you tell me what is the moment? This force df into y. This force df into y. So therefore, it is df into y, and that is, what is df? Rho gx dA into y. Okay, no problem at all. No problem at all. Okay. So total moment should be equal to, इंटीग्रेट करो इसको, इंटीग्रेट करो, टोटल मोमेंट इंटीग्रेट करो, rho gx dy. This is the moment of only small force. This is the moment of only small force. And I repeat, this is the moment of only small force. If you want total, integrate karo, integrate. I have integrated. So can anyone tell what is this? What is this? It is the moment of the hydrostatic force about OO dash, about OO dash. Now I'll tell you simple mechanics की बात बताता हूँ. सुनो. All of you, my dear students, are we clear? What is this? Anyone? What is this? It is the moment of the force about OO dash. About OO dash. We have taken moment about this line. Okay, no problem at all. About this line. Not at all a problem. Okay, listen now. You have seen from mechanics, simple mechanics, बात बताता हूँ, सुनो इधर. Let this be the free surface. Now, see, my dear students, let this be the center of gravity. G. Can anyone tell where is the center of pressure? Okay, one more thing. Now tell me, where is the center of pressure? Where is the center of pressure? It will not, definitely it will not be at G, but it will be below G. So I don't know where it is. Honestly, I don't know where it is. It is my effort to find out that position. So therefore, let this be the center of pressure. Yes. Can you tell me what is this? देखो, center of XCP. What is XCP? It is the vertical distance of, देखो, this is xcp. Yeah, this is the position. And please tell me, where is hydrostatic force acting? Will it act at CG or CP? Whatever the force we have calculated, WAX bar, WX bar, where is that force acting? It will not act at CG, but it will act below CG. Because with depth, the pressure is increasing. And how will that force be acting? It is always normal to the area, normal to the area, normal to the area. Normal to the area. Now, let us take the moment of this force about this. I will write this as it is Cp. देखो, I will write this as YCP. Always remember, please understand carefully. It's very clear. एक बार देखना. Very clear. देखो एक बार. अगर ये x है, तो ये y है. अगर ये x बार है, तो ये y बार है. If it is xcp, this will be ycp. If it is x, it is y. If it is x bar, it is y bar. If it is xcp, it will be ycp. Very good. So this is ycp. Now what we do is, let us take the moment of this resultant force about OO dash. Let us take the moment of this resultant force about OO dash. Can you tell me what is the moment? It will be F into, what is the moment of this force? Resultant force. Resultant force. Moment of this F into YCP about this. So therefore F into YCP. Very good, my dear students. So whether I take this or this, I should get the same thing. I should get the same thing because this is, देखो एक बार, arbitrarily I am assuming somewhere. So for equilibrium, what is this? Please listen. Can anyone tell what is this? What is this? It is the moment of, okay, एक सेकंड मैं यहाँ बताऊंगा. हाँ, अब देखो, what is this? It is the moment of this force about this. Means integrate किए तो total moment of this total force about this. ये भी वही किए, total force about. So this is giving me the moment, this is giving me the moment. So therefore both should be same. So let us equate. This is giving me the moment of the total force about y dash. This is giving the moment of total means integrate k. Already we have calculated F. It is the total force and we have taken moment about this. So this is giving the moment of total force about this. It is giving the moment of the total force, integration total force about this. So both should be same from my mechanics. Both should be same. So let us equate both. Let us equate both. So integral rho gxy dA must be equal to F into ycp. Okay, please stop. And integral, so rho g to constant hai, take out of the integration. Rho g is constant, take it out of the integration. Xy dA is equal to F. What is F? WAX bar. F is WAX bar. F is WAX bar. Already have calculated. What is hydrostatic force? WAX bar. This is WAX bar. I repeat, this is already we have calculated WAX bar. So I am writing WAX bar. F into YCP. So into YCP. But W can be written as rho g. So therefore rho g integral xy dA is equal to W. What is W? What is W? Rho g. Rho g. So rho g AX bar YCP. So rho g is gone. Now we are left with integral xy dA is equal to AX bar YCP. Stop, my dear friends. Already I gave you the relationship. What is the relationship? What is the relationship? Already I gave you. If it is x, it is y and theta. So therefore x is equal to y sine theta. X bar is y bar sine theta. XCP is YCP sine theta. All these I have told you. So therefore x को क्या लिखेंगे? What can I write? देखो integral x को क्या लिखेंगे? Listen, x, what is x? Y sine theta. Y sine theta
You have written x as y sin theta, but already there is one more y. You have written x as y sin theta, but already there is y. So one more y is there. So y square sin theta into dA is equal to a x bar. What is x bar? What is x bar? Y bar sin theta. So therefore y bar sin theta. Y bar sin theta. This x bar can be written as y bar sin theta into ycp. Absolutely fine. So I think sin theta is constant. Sin theta can be taken out. Integral y square dA is equal to a y bar into a y bar. देखो एक बार a y bar into ycp. So therefore ycp will be equal to integral y square dA by a y bar. I repeat, if you want ycp, integral y square dA by a y bar. Now please stop. Let us see what is y square dA. Integral y square dA. Please look at my dear students. Let's see what is integral y square dA. Y square dA. Look at my dear students. Let's see what is y square dA. All of you, till now is it clear? It is a very important derivation. Till now is it clear? Till now is it clear? All of you, till now is it clear? All of you, till now is it clear? Only Navlesh, Dilip are saying yes, sir. Shabas, Ashwin, okay, Aditya, Bharat, then that's all. Rajesh, Sai Jishnu Adluri, clear? Rasagna, Sam Dhanraj, he joins, leaves. Shubham, Rajendran, clear. Okay, Viraj, yes sir, clear. Okay, there are many. Chalo, let's proceed. Shivam Srivastav, excellent. Clear? Now, chalo. Hemant Kumar, chalo. Now stop. Can you tell the meaning of y square dA? Please listen carefully. What have you done? Look at. Listen. You have taken a small area. देखो एक बार. We have taken a very small area. And that area is dA. And this is देखो. Listen, my dear students. We have taken a small area. And what is the moment of that area about O dash? It will be something like moment of force into perpendicular distance. So instead of moment of force, I am taking moment of area. So RR, what is the moment of force? F into perpendicular distance. So what is the moment of this area? It will be dA into y. About this you are taking, about this. So what is the distance between these two? It is y into a, y dA. Very good. See, I'll tell you, what is the first moment of area? Area into y. It is the first moment of area. Now let us take the second moment of area. मतलब दूसरी बार ये first हो गया. Again you take the moment. When you take the moment, it will be y into y. First इस area का moment यहाँ पे ले रहा है. You are taking the moment of this area about this, so it will be dA into y. You take again the second moment, dAy into y, and this y square dA is known as second moment of area, and that is known as moment of inertia, which we'll be studying in mechanics and SOM. Don't worry about that. It is known as moment of area. So now tell me about what axis you have taken the moment. You have taken about this. You have taken moment about this. We have taken moment about this OO dash. We have taken moment about O dash, and that's why it is written as IOO dash, because it is taken. See, if I do not derive this derivation, if I do not derive this equation, and in examination he will ask from the middle, then you will just remember and you don't answer. I know. That's why I have derived. There is a reason. So whatever we are doing completely and perfectly. So therefore, what is this देखो y square dA? It is the moment of this area. So when I integrate with the complete area. When I integrate, it is a complete area. It is the moment of this complete area about this. You have taken moment about this. We have taken moment about this OO dash O dash. That's why I write this as IOO dash. So therefore, now I write this as देखो एक बार. So YCP is equal to, listen carefully. So IOO dash, this is IOO dash by AY bar. IOO dash by AY bar. Now stop. Let me try to convert. This is my fundamental equation. And from this equation, let's try to move ahead. ये मेरा equation है, यहाँ से आगे बढ़ेंगे. So from here, let's try to move ahead. Look at. Now, okay. Let this be the center of gravity. Can I write this as y bar? Because this is the center of gravity. Center of gravity. मतलब ये x bar है. If that is x bar, if this is x bar, this will be y bar. This will be y bar. If this is x bar, this will be y bar. Okay, no problem at all. Now, my dear students, let the area of this be A. इसका area. This area. So this area is A. The area of this is A. इसका area. I'm talking about this area. This area. Let it be A. Okay. No problem. Let it be A. अब देखो. You have studied parallel axis theorem. Listen, my dear students. This is GG, centroidal axis. This is GG. If you want the moment of inertia about any parallel axis, ये दोनों parallel है देखो. This and this both are parallel. And what is the distance between them? What is the distance between centroidal axis and OO dash? It is y bar. Okay. Now, you know, my dear students, my parallel axis theorem, which you have studied in 12th class or engineering first year, it says, you should know this also because you have completed engineering. अब ये भी नहीं आता तो people will laugh at us. If you want the moment of inertia about any axis which is parallel to the centroidal axis, ये तो centroidal axis है, and this is centroidal axis, and this is parallel axis. If you want about this axis, it will be the moment. If you want the moment of inertia about this axis, my parallel axis theorem says, if you want about OO dash, my parallel axis theorem says, if you want IOO dash, it will be IGG plus area of this into the distance between these two axes. The distance between square of the distance between these two is y bar. So my parallel axis theorem says IOO dash will be equal to IGG, which is parallel to this, IGG, which is parallel to this, plus area of this into ये दोनों के बीच का distance कितना है y bar square. This I got from parallel axis theorem. Don't blame me. This is a simple derivation from your parallel axis theorem, engineering mechanics. Is it clear, my dear students? Now what I do is I will substitute here. देखो एक बार YCP is equal to YCP is equal to IOO dash. What is IOO dash? What is IO dash? I'm substitute. देखो YCP is IOO dash. What is IOO dash? It will be IGG plus AY bar square. Okay, this is IOO dash. This is IOO dash by AY bar. So therefore YCP is equal to, divide करना, इसको separate करना. Y bar, if you separate y bar gets cancelled, a gets cancelled, so only one y bar will be left. So y bar plus ये divide करना. You divide these two. What do I get? It will be IGG by AY bar. But everyone knows. देखो XCP is YCP. Already I had told you sin theta. So x bar is equal to y bar sin theta. All these I have told. So what is YCP? Can I write YCP as XCP by sin theta? Yes, XCP by sin theta. Y bar. What is y bar? From this, what is y bar? X bar by sin theta. X bar by sin theta plus IGG by A. What is y bar? X bar by sin theta. X bar, that sin theta will go to the top. So I have written y bar as x bar by sin theta. X bar by sin theta, it will go to the top. So therefore, now XCP will be equal to, you take sin theta, you take sin theta to this side. So this sin theta is gone. This is x bar plus IGG by AX bar. This sin theta will come this side. This sin theta will come this side. So it will be sin square theta. This is the, please note down that now I will give you two things and try to understand those two things. एक second. Yeah, I'll give you two things. एक second. Now understand these two things. So क्या है? YCP is y bar, this equation. This is one equation and this is another equation. YCP is y bar plus IG by AY bar. YCP is y bar plus IG by AY bar, and XCP is x bar plus IG by AX bar sin square theta. Let me check. Yeah, I will tell you very clearly now. Please look at. Please understand. Let us assume that this to be a free surface and there is an object. Look at. There is an object. Let this be the center of gravity and this we write it as x bar. Now, where from the force is acting, it will not act at CJ, but it will act at CP. Where from the force is acting, it will not act at CG, but it will act at CP. The hydrostatic force F. Already we have calculated the magnitude, and this is our XCP, and the same can be written as YCP. My dear students, if you want the position of the center of pressure, so if you are measuring from this, if you want this, it will be this. If this is my YCP, देखो एक बार, this is my YCP, and if you want XCP, if you want the position, if you want vertical, it will be this equation. If you want inclined, it will be this equation. In examination, you may be by hearting this, but he may give this, you will be in trouble. And now tell me what is IG. Just now we have seen, देखो एक बार, this is the area, and you saw O dash, this is my IG. Very good. So if this is B and if this is D, what will be the moment of inertia about this axis, about this axis? Anyone? So if you want IG, if you want about this axis, it will be B d cube by 12. If you want about this axis, it will be B d cube by 12. So therefore it will be B d cube by 12. Please tell me, is the derivation clear, my dear students? Is the derivation clear? So I can express the position of center of pressure either in vertical fashion or in inclined fashion. If it is inclined fashion, it will be YCP. It will be YCP. And if it is a vertical, it will be this. Please tell me, is it clear? All of you, is it clear? This is a wonderful derivation, my dear students. Come on, tell me, is it clear? And we are going to solve some beautiful questions on this. And you should know about what axis the moment of inertia is taken. All of you, just tell me. If it is clear, then I'll proceed. Clear? Clear. Yes, no? Very good, my dear students. Absolutely fine. Mind blowing. No problem at all. Up yahan se, we'll go to, from here, now we'll go to inclined and, sorry, already we have seen inclined. Now from here, we'll go to vertical and horizontal plane surfaces. This x bar will, yes, the x bar, it gives us the position of, then pi by 64 d power 4. If it is a circle, yes, I'll be doing now. If it is a circle, it will be pi by 64 d power 4. And one more thing, x bar will give me the position of center of pressure. It gives, yes, in this case, it is giving just the magnitude of where that force is acting. It will give, that's it. And depending on the depth of immersion, we can correlate between x bar and xcp. We can correlate between these. Very good, my dear students. अब आगे बढ़ते हैं. Now we'll proceed further. Now have a look at this. Now finally I'll show you the resultant diagram. Let me show you the resultant diagram. Yes. Finally, yes, suno. finally the resultant diagram will be like this. Yes. Yes, my dear students. So the total force is given by WA x bar. Can you tell me what is x bar? It is the vertical distance of center of gravity from the free surface. All distances are measured from the free surface. All the distances are measured from the free surface. And what is XCP? Vertical distance of center of pressure measured from the free surface. एक छोटा सा एग्जाम्पल बताऊंगा. For example, so let us take a simple example so that you can have a better understanding. What is that? I'll tell you. What is that? To have a better understanding. So for better understanding, let me put it this way. For better understanding, yes, let us assume, देखो एक बार, let this be 1, some 5. Okay. Now, very simple, my dear students. Let x bar be some 2.5 meter, जो भी है, whatever it may be. So what is x bar? So the center of gravity यहाँ पे है, vertical distance, okay. And if you want the magnitude of force, very simple, my dear students. And this is the centroidal axis. This is GG. Can you tell me what is IGG? अभी तो बताया. What is IGG? If you want the moment of inertia of this, it will be B. So IGG, it will be B d cube by 12. So in this case, it will be 1 into 5 cube by 12. What is the area? The area is 1 into 5. Yes, my dear students. So how do I calculate the force? WA x bar. What is W? Rho G. Rho is 1000. G is 9.81. If it is water, rho G. Area. What is the area? 5 into 1. X bar 2.5. You will get the value of this force. Now, where is that force acting? Please Mr. Srinath Reddy. If the body is immersed something like, look at carefully. I'll be taking up that case now, don't worry. Yes, don't worry. I'll be taking up that. If it is immersed only up to this partially, there is no force. So we will be taking only this portion, only because the force is coming only on this portion. So please note down carefully. We'll be taking only that portion which is below the surface. Yes, only that portion which is below the surface. Not above, not complete body. The force is coming only on the body which is submerged. So only the body which is submerged will be taken into consideration, not the complete body. Anyway, I'll be taking up that case. Okay, na? Okay. Now. Clear, Mr. Srinath? Only that portion of the body. I'll be taking up that in numericals. Don't worry. Very good. So now I want XCP. Just now I derived the equation. So let this angle be some 30, whatever it may be. Some angle, I don't know, let it be theta. So therefore, x bar plus abhi gaya, IG by AX bar sine square. Just now I derived this equation. IG is known. area is known, x bar is known, sin theta is known. I can easily calculate what? I can easily calculate x bar, no problem at all. Now we are dealing with what? We are dealing with plane surfaces. In plane surface, just now we have completed inclined surface. Now I'll go for case 2. Plane vertical surface. We'll take plane vertical surface. We'll take up plane vertical surface. अभी हम plane vertical surface ले लेंगे. चलो, understand now. We'll take up plane vertical surface. ये देखो. First हम inclined ले लेंगे. Okay. Now we'll take up the plane vertical surface. Okay na? Chalo. How do I get vertical? How can I convert this into vertical? इसको vertical बनाओ. Yes, this is the vertical surface. This is the vertical surface. This is the vertical surface. So, can you tell me what is theta? If you just see what is this angle? So, this is our G D dash. Yes. Yes. Ab dekho, please listen, my dear students. Please listen. So, what was the equation and where will be that force? It will act here. That is F. And in this case, you know that F is WAX bar and XCP position is given by X bar plus IG by, already we have derived this equation. Now, let's try to draw the pressure diagram. Let's try to draw the pressure diagram. And my dear students, let this length, let this length be x1 and let this length be x2. You know very well, if this is the plane surface, vertical surface, this is the area, on which the fluid is exerting. Arya, I am showing on one side. If there is a fluid on other side, there will be force on other side also, but I am showing on one side. So what will be the force? It will be normal. It will be normal to this. इस surface को normal होगा. So, and with depth the pressure is increasing. So it is always normal to the area. So therefore, we will show it clearly. Yes. Yes. What will be the pressure here? Yeah. So what will be the pressure here? It will be rho g x1. The depth is x1. It will be rho g x1, rho g x1. What will be the pressure here? The depth is x2. It will be rho g x2. And how is pressure varying? Linearly. So the pressure is increasing with the depth. This is nothing but your this is your pressure diagram. This is our pressure diagram, and we have seen the pressure diagram, no problem at all. अब देखो कहाँ फोर्स एक्ट कर रहा, वेरी सिंपल माय डियर स्टूडेंट्स, इसको थोड़ा एक्सटेंड करेंगे. Yeah, this is the pressure diagram. Now, already I have the equation. Just put theta is equal to 90. So what do I get? So in force equation there is no theta. Therefore, if you want the force, just put theta 90. There is no theta, so you will get this as WAX bar. And what about the position of center of pressure? Just put theta 90. When theta is 90, sine 90 is 0. Sorry, sine 90 is 1. Sine 90 is 1. So it will be x bar plus Ig by Ax bar. XCP is x bar plus Ig. Sine 90. Sine 90 is 1. This is the position of center of. But yahan suno, in this equation, can you tell in this equation what is IgG? It is the moment of inertia about GG which is parallel to O dash. मतलब इसमें IgG क्या था? What was IgG? It about this axis. It will be B d cube by 12. This is B d cube by 12. But when I turn it through 90 degree, अब ये बन जाए. If I turn it through 90 degree, see actually my dear students, it was like this. देखो एक बार, it was like this. About this axis, एक second, about this axis. It's like this, एक second. Yeah, this is the plane surface. So we have seen IgG. This is IgG. Means this axis. इधर देखना. It is this axis. This is IgG. So look at the screen. IgG. This is IgG. अब मैं क्या कर रहा हूँ इसको? Now this is the angle. अब देखो, this is the angle. Now I have turned like this. So originally it was about this axis, IgG, incline. In incline it was about this axis. Now I turn it through 90 degree. When I turn it through 90 degree, it is about this axis. Can you tell me what is this? देखो, ये वाला. And please note down that it will become this one. It will become this one. And can you tell me what is this axis? It is parallel to the free surface. So in this case, IgG will be about this axis. So इस case में ऐसा था. If you turn it through 90 degree, it will become. If you turn it through 90 degree, it will become parallel to free surface. So I will write this as it is the moment of inertia of the area, which is of the area about centroidal axis. About centroidal, this is centroidal axis, this is centroidal. So we are calculating about centroidal axis, which is, देखो, how is this line parallel to, this is the free surface, this one, ये दोनों क्या है parallel, which is parallel to free surface, which is parallel to free surface. Please, so in this case, what will be the moment of inertia about this axis? It will be B, about this axis, it will be B d cube by 12. So in this case, इस केस में it will be B d cube by 12. अगर circle होता है तो pi by 64 d power 4. Please tell me, are we clear? Now let me show you the complete part of this. ये सरफेस है, let this be the center of gravity. Now you know very well where will be the center of pressure, anyone? So with depth the pressure is increasing, so definitely it will not be at CG, it will be below, because depth के साथ pressure बढ़ रहा है. With depth the pressure is increasing, so the resultant force will shift to the bottom because the pressure is increasing with depth. So therefore now this is our X bar, and this will be our CP, which I rate as XCP. And how is that force acting? The force is acting normal. Yes, that force is acting normal. It will act, always remember, hydrostatic force will act at the center of pressure, not center of gravity, at the center of pressure, and that will lie below the center of gravity in case of inclined and vertical surfaces. Please tell me, up to this, are we clear? All of you, are we clear? Bolo. Is it clear? If it is clear, I'll proceed. Clear? Clear? You're not saying anything. All of you, are we clear? What is happening? Is it clear? Waiting for your response. Yes. Very good. Clear? Awesome. Ashok Naik. Very good, my dear students. Excellent. Chalo. Now we'll go to excellent, my dear students. To plane horizontal surfaces. Now we'll go for plane horizontal surfaces. Okay, chalo. Let's go to plane horizontal surfaces. Yeah. It's like this now, all of you. It's like this. This is the plane surface and horizontal. It is a plane horizontal surface. Now let us try to calculate the hydrostatic force on this plane horizontal surface. Let's try to calculate the hydrostatic force on this plane horizontal surface. Plane horizontal surface. Very good. Chalo. So how do I get? You see, if you see, this is inclined. This is inclined. How do I get horizontal? देखो, if you want horizontal, this angle, just देखो एक बार. पहले देख, एक second. Listen all of you. एक second. It's like this. This angle is theta. So theta is decreasing, decreasing. Theta कम हो रहा है. And if it is horizontal, the angle between this and this is 0. And if I make it like this, vertical 90, theta, देखो 90, theta is decreasing, 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 0, 0, 0. So if I put theta 0, I'll get the plane horizontal surface. I'll get plane horizontal surface. Okay, no problem at all. Now, let this be the center of gravity. So I will write it as x bar. Now, I'll write this as x bar. Okay. Now, what will be the pressure here? First, we'll see what is the pressure here. Pressure at any depth. Pressure at any depth is rho g x bar. Is depth पे rho g x bar. Now tell me what is the pressure here? What is the pressure here? Anyone? So all are at the same depth. This is at x bar, this is at x bar, this is at x bar, this is at x bar. All at the same depth. So pressure will be same everywhere. Why the pressure is same everywhere? Because all are at the same depth. This becomes our pressure diagram. All are at the same depth. Very good. My question to you people is, if all are at the same depth, in previous case, with depth the pressure is changing. Arey Baba, with depth the pressure is changing. But यहाँ पे all are at the same depth, where will be the force? Obviously, when all are at the, okay, chalo, we'll do one thing. We'll take the previous case. Inclined ले लेंगे. F is WAX bar and XCP is equal to X bar plus IG by AX bar sin square theta. Put theta is equal to 0 degree. So when you put theta, इसमें तो कोई theta नहीं है, so you'll have the same equation. There is no theta here. You'll have the same equation. So therefore, XCP is equal to X bar plus IG by AX bar sin square. Theta is 0. So sin 0 is 0. 0 into something is 0. So XCP is equal to X bar. It means the center of gravity and center of pressure, they coincide. Why do they coincide? Common sense says everywhere. In previous case, it was below the CG. The reason is with depth the pressure is increasing. But all are at the same depth. When all are at the same depth, it will coincide with CG only. Yes, it is a live proof here itself. Why it was shifting down in previous case? Because with depth the pressure was increasing. When all are at the same depth, it will coincide. Therefore, this will be also our center of pressure. This will also be our center of pressure. So therefore, in this case, so if I show the resultant one, the diagram, this is the free surface. This is hydrostatic force. this is not only CG, but this is also CP. So therefore here X bar is equal to XCP, both are same, absolutely fine, no issues at all, no issues at all. Please tell me, is it clear? So how simple it is. And what I do is I'll put all in one table for your easy understanding. So in case of horizontal surfaces, the center of pressure and center of gravity coincide, but always remember that the hydrostatic force will act at the center of pressure. But in this case, luckily, CG and CP are coinciding. Okay, no problem at all. So I'll ask you one question. Tell me. Let us take vertical surface. Let us take plane vertical surface. You know that for plane vertical surface, XCP is, yes, question. In case of horizontal में तो CG CP coincide, leave aside. In case of vertical, this is vertical surface when theta is 90. Tell me, under what conditions center of gravity and center of pressure are almost the same? Under what condition center of pressure and center of gravity are almost the same? Almost the same. Just tell me. This is the question. Under what condition CG and CP are almost the same? Tell me. The question is, in vertical surfaces, under what condition CG and CP are almost the same? CG and CP are almost the same. Come on, Ben. But when you are saying IG and X bar are approximately equal, when pressure is same and all. See, I'm not talking about horizontal. If it is horizontal, it will be same. Large area. Oh my God. Large area. Srinath, large area. Sonupriya, you said pressure is same at all points. You know, pressure is same at all points only for horizontal. वो तो है coincide होगा. I'm talking, अरे leave रे, horizontal तो है. Leave horizontal. I'm not talking about horizontal. I'm talking about vertical. Infinite length. Infinite length. Oh my God. Someone said large area. What they thought is, if the area is large, you thought this denominator will be large, this will be negligible, so both will become same. But you know, area is, it depends on the geometry, B and D. If the area is increasing, B and D, for example, you have something like this. This is B, this is D. Let us increase the area. Okay. But if, what is moment of inertia? BD cubed by 12. And if you increase the area, what would happen? If I increase the area, what would happen to this? This will also increase, na? What would happen to D? This will also increase, na? So if I increase the area, the moment of B and D are increasing. So both are related to geometry. I repeat, both are related. Navalesh, very good. So therefore, both are interrelated. IG and A both are interrelated. ये दोनों interrelated है. If both are interrelated, if this decreases, this decreases. If this increases, this increases. So कुछ मत करना. Increase X bar. Increase X bar. What do we mean by that? Listen carefully. If X bar is increased, these two are fixed. I'm not changing the dimensions of the surface body. So if these two are constant, when X bar is increasing, this will increase. जब ये बढ़ रहा है, तो ये क्या होगा, नेग्लिजिबल, ये नेग्लिजिबल होगा, x और xcp क्या होगा, सेम होगा, सेम, ऑलमोस्ट सेम. सो देयरफॉर नाउ आई राइट, देखो इट्स लाइक दिस. Yes. Now the same body, same body, width B, depth D. Can you tell me the meaning of x bar? X bar का meaning क्या है? It is the vertical distance of center of gravity measured from the free surface. So vertical from the free surface. This is our x bar. This is our x bar. This is our x bar. So अब देखो, what is xcp? xcp is x bar plus, yes, when x bar is increasing, देखो एक बार, when x bar is increasing, ये तो constant है, my b, d, area, all those are constant. When x bar is increasing, this value will decrease, so this will become negligible, both will become almost same. So now I read xcp and x bar are almost same at larger depths. Please tell me, is it clear? At larger depths. Okay na? Chalo. So now I'll give you one table. What is that table? So that the revision will be very easy for us. Let us take one table. Inclined, vertical, horizontal, and in all the cases you have seen it is WAX bar. Where is the center of pressure? I gave you already, X bar plus just remember this table. It is enough. Just remember this table, it is enough. But this is for plane surfaces. It is for plane surfaces. Single table enough. Single table, it's enough. This is for plane vertical surfaces. Now, what we do is, we'll try to do a certain important एक काम करते हैं, very important table. This is very important table. Okay, shall I proceed? Okay. Now I'll take one example. Let this be the free surface. मान लो ये free surface है. This is a free surface, and there is a rectangular surface, and it is like this. This is the top edge of the rectangle. This is the bottom edge. So it's not kept like this. It's not kept like this. It is kept like this. And there is a fluid this side. Let us say there is a fluid this side. The top edge is coinciding with the free surface. And अगर आप इस side से देख रहे हैं, if you see from this side, इस side से, so this is the free surface, this is the free surface, and the top edge is coinciding. Okay. Take a rectangle. Let the width be B, depth be D. Now you know that the center of gravity, where will be the center of gravity? We are taking homogeneous bodies. Where will be the center of gravity? You know, अगर इसका depth D है, अगर depth D है, I will write this as D by 2. Tell me what is X bar. X bar is always vertical distance of CG taken from the free surface. X bar is vertical distance of CG taken from the free surface. Okay, X bar. And what is the area? You know, the width is B, depth is D, so area will be BD. Let us try to calculate the moment of the center of pressure, and this is my centroidal axis. Okay, na? Chalo. Can you tell me the moment of inertia? Already we have seen it is the moment of inertia about this axis. About this axis. Can you tell me the moment of inertia about this axis? It will be B d cube by 12. Already we have seen for plane vertical surface, the moment of inertia is nothing but what? About the centroidal axis which is parallel to this. About the centroidal axis which is parallel to this. Centroidal axis parallel to this. So therefore, I will write this as B d cube by 12. This is B, and this is d cube by 12. Okay, no problem at all. So now let us calculate the center of pressure, depth of center of pressure. Already I gave you for plane vertical surfaces it is X bar plus Ig by Ax bar. X bar plus Ig by Ax bar. Okay, so let us calculate XCP. What is XCP? X bar. What is X bar? Already you know X bar is what? D by 2. Ig. What is Ig? It is BD cube by 12. By Ig by area. What is the area? BD. X bar is D by 2. I repeat, my dear students. XCP is X bar plus Ig by X bar. XCP X bar. What is X bar? D by 2 plus Ig BD cube by 12 by area. What is that area? BD. X bar. What is X bar? D by 2. Absolutely. Now let us calculate XCP. D by 2 plus BD cube by 12 into this 2 will go to the top. This 2 will go to the top. This will be BD square. Now this B is gone. D square D, 2 1s 2 6. So this will be XCP is equal to D by 2 plus D by 6. So how much is this? कितना आ रहा है ये? तो multiply with 3, 3 plus 1 is 4, 4 by 6, 2d by 3. Obviously, and the position of center of pressure is 2d by 3. And this is the important result, my dear students. And you should not waste your time in examination. Okay, if this is d by 2, if this is d by 2, this will be 2d by 3. If this is d by 2, this will be 2d by 3, 2d by 3. Obviously, 2d by 3 is more than d by 2. Obviously, and please listen, my dear students, you have to, please listen. You have to remember this. The reason is, I repeat, the reason is, you have to remember this because many questions have come from this when the top rectangle with top edge, and please note on that this is valid only when the top edge of the rectangle is coinciding. So I'll give you a simple point here, that is, if this is a rectangle, let us assume that its depth is 6 meter. मान लो, let us assume that the depth is 6 meter and all distances are measured from the free surface. Let us assume the depth is 6 meter and all the depth is 6 meter. The depth is 6 meter. The depth is 6 meter, 6 meter, 6 meter, 6 meter, 6 meter. And look at, this is 6 meter. So where will be the center of pressure? Where will be the center of pressure? Now in about 5 minutes, I'll be stopping this class and I'll be taking the doubt session on thermodynamics. I repeat, my dear students, after the completion of this part, I'll be taking up doubt session on thermodynamics. And those who want to leave, they can leave. And those who want to attend thermo doubt session, they can attend. I'll be taking up some good questions and daily. I'll be taking up, whenever I get time, I'll be taking up your questions on doubt sessions. Okay, chalo. So if this is your 3 meter, listen. Dekho, what is the total depth? 6. So where will be the center of pressure? Center of gravity. Center of gravity will be, agar ye 6 hai, so it will be 3. So where will be the center of pressure? Anyone? Where will be the center of pressure? Idhar dekho. Just now you told 2d by 3. 2 by 3 d. What is the